Hi, and welcome to another nostalgic math chat. Are you ready to ramble? Let's do it. So, we are looking at the department's paper 2 from May 2023. Question 4, which is giving analytical geometry with some circle flavor. Let's get into it. In the diagram, the equation of the circle centered at n negative 12 as its x coordinate, 5 as its y coordinate, is x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. Okay, so they've given us the center explicitly, but they haven't given us the radius. Okay, cool. The equation of the circle centered at M is x plus 6 squared plus y plus 3 squared is equal to 25. Okay, cool. PS and PR are tangents to the circle centered at M, at S and R respectively. Okay, that was confusing. Okay, so P and S are tangents to the circle that is centered at M, and they are tangents at the point S and R respectively, not respectfully. Right, PR is parallel to the x-axis. I'm just going to go right ahead and fill that in because that might come in handy later, and I will probably have forgotten that they said that. Okay, and then K, okay, so they give us the coordinates of K, negative 17, negative 5, is a point on PS. Okay, cool. The straight line joining N and M cuts the smaller circle at T and the larger circle at S. Whew, essay, a whole essay inside mathematics. Right, so let's see what the first question is. They ask us to write down the coordinates of M. So the coordinates of this guy over here, the center of this circle, right? And they did give us the equation of that circle. They gave it to us over here. So we can then see that the coordinates of M are negative 6 and negative 3, right? Because remember, the equation of a circle, the standard form looks like this, where the center of the circle is A, B, and the radius is R. So if we have x plus 1 squared, blah, 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 that's the same as x minus negative 1 squared plus whatever. So that negative 1 will be the x coordinate of the center. Right. Cleaning up, and some more cleaning up. Right, so we now know that the coordinates of M are negative 6 and negative 3. Okay, right. Then we are asked to calculate the length of the radius of the smaller circle. And how do we know which one is smaller? Okay, so right, they kind of imply it over here. Okay, the straight line joining N and M cuts the smaller circle at T. Okay, so by implication, that is the smaller circle. We can't just look with our eyes, because remember, they keep emphasizing these things are not drawn to scale. They're not drawn to scale, so you can't just say it looked like the smaller one, therefore it is the smaller one. So if they hadn't hinted it here, for example, that this is the smaller circle, what you would have needed to do is to find the length of the radius of this circle, because we know that this circle has a radius of 5, the square root of 25, but we don't know what the radius is over here yet. So you'd have to find the length of the radius by doing the whole completing the square situation, and then you'd have to say, okay, cool, now I can see that the radius of this one is 2, whereas the radius of this one is 5, so this is therefore the smaller one, and then proceed from there. Okay, but anyway, we don't need to do all of that because they've told us which one the smaller one is. Anyway, so we want to find the length of the radius of the circle centered at N. Okay, so they did tell us the coordinates of the center, so I'm thinking that could decrease our work a little bit. Potato. So I'll do it two ways, right? So let's start the standard way. The standard way would be, okay, let's try not to write on the picture. So the standard way would be to complete the square. So you'd have x squared plus 24x plus 24 over 2 squared. And then we'd have y squared minus 10y plus negative 10 over 2 squared. Okay, and then we just have the random constant chilling over there, is equal to, and then we'd add the same constants on the right hand side as well. Okay, so now we can then express these three terms as a single term. So that would be x plus whatever 24 over 2 is, it is 12. Okay, and y minus 5, right? Minus 5 is coming from here, negative 10 divided by 2. Okay, and then we've got, it would have been so much easier to just do it. And I think I have started writing on the, let's do it here. Knew it. Oh dear. Why are you moving actually? I'm not sure. Okay, left a whole lot of stuff behind. Okay. Okay, right. So that would be equal to 0 plus 12 squared, which is 144, plus negative 5 squared, which is 25. So I think that comes to 169. And there's a plus 153 over here. Sorry, this guy. And if we minus it from both sides, then we end up with x plus 12 squared plus y minus 5 squared is equal to 169 minus 153, which is 16. So from there we would know that the radius is the square root, the positive square root of 16, which is 4. So it would be 4 units long. So that would be like kind of the standard way of approaching this question. But I want to just show an alternative. And I'm actually just wondering if it would even be shorter, or, but let's see. So I'll keep that there. Right, so the key thing here is that they have already told us the center of the circle. So we're almost there. We just need to know what R is. So what we could do is, okay, we know that the equation looks like this, right? Because the center is negative 12 and the y-coordinate of the center is positive 5, okay? So then, so that would be x squared plus 12x plus 12x plus 144 plus y squared minus 5x, so minus 10x plus 25 is equal to r squared, okay? And then we could say, okay, so that's x squared plus 24x. In fact, just try to write this similar to how it was given to us. So similar to this equation. So we would have x squared, okay, so that's that term, plus y squared, which is that term, plus 24x, which is this term, minus 10. Oh, where did I get an x over here? Golly. So that is a y. Minus 10y. Okay, so that's that term. And then we have 144 plus 125. So that would be plus 169 is equal to r squared, right? And if we compare it to the initial equation we were given x. Oh. I'm trying to fit everything into one frame. Okay, but you need to make this smaller. Come on. Okay, so the initial equation is x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. So if we, from this one, minus r squared on both sides, right, we're going to end up with a 0 on this side, right? This side becomes 0, which is what we want here. And so that means this bit over here must be equal to 153, right? So 169 minus r squared must be equal to 153, which means r squared must be 16, and so r is 4. So that would be another way that you could approach this question, given that they gave you the center already. Okay, and then 4.2.2, I'm just going to move these guys down actually in preparation for that. And this is me seriously hoping that I have not touched the diagram. I feel like I'm becoming pro at this now. Get rid of that little square, get left behind. It belongs here. Okay, and this belongs, spoke way too soon, bragged way too soon. Thou shalt not brag. Okay, let's just clarify where that is coming from. I'm going to highlight this. Okay, anyway. Right, so we now know that the radius of this circle is 4. Right, okay. Next question. Write down the length of TS. So this little bit over here between the circles. Okay. So that's pretty cool. We know the length of this radius is 4. We know that the length of this radius is 5, okay, from the equation of the circle as given to us. So if we can find the distance between M and N, right, and subtract, well, let me just write down here, R is equal to 5, and subtract the 4 and the 5, then we know what this little bit is. So let's do it. So 4.2.2. So let's find what MN, the distance between M and N is. So that'll be negative 12 minus 6, which is just plus 6. Okay, and then 5 minus 3, which is just plus 3. Okay, so that'll be 36 plus 64, which is 100. So that is 10 units. Okay, right. Then we know that NT is equal to 4 because it's a radius of a circle N. And we know that SM is equal to 5 because it's a radius of the circle M. Okay, so then as such, okay, this one, okay, I'm just going to squeeze it in. Therefore, TS is equal to 10 minus the 4 and the 5, which is 10 minus 9, which is 1 unit. Okay, yeah, I thought I had piece, but I don't really have piece here. I'm just going to shrink these a bit. And I'm going to erase this and draw it again. Wiggly, wiggly, wiggly. Okay, cool. So let's see what the memo thinks. So for our first answer, if I can find it, the coordinates of M are -6 and -3 indeed. And then the length of the radius is 4 units. And then TS is indeed 1 unit long. Okay, on a good path. On to the next. So just going to fill in what we know. R is 4. Oh, that's not great. Let's try that again. R is 4 and R is 5. And these are parallel. Okay, right. So the next question asks us to determine the equation of the tangent PR. Okay, so this is cool. So because PR is parallel to the x-axis, we know that it's a perfectly horizontal line. So its equation is going to be something like y is equal to some number, right? So in order to find that number, I'm feeling like we can use the fact that M and R, so if we connect MR, that is obviously a radius, and this is a tangent, and so we know that this is 90 degrees. So that means that if the coordinates of M are -6 and -3, as we determined earlier, then we know that R, because it's perfectly vertically below M, that means that R's x-coordinate must also be -6, and then the y-coordinate will be 5 units down from -3, right? Because we're going in a perfect vertical line down from M to R. So we can just then subtract 5 from -3. We're going lower, so we're going to subtract. So the coordinates of R would be -6 and -8. And so the equation of PR would be y is equal to -8. So let's just see if we can write that a bit more formally. Okay, so we know that MR is perpendicular to PR because of tan rad. Okay, and so therefore R is directly below M. Okay, so that's very important, because if it wasn't the case, if M was here and R was here, right, so there's a slant there, it's not directly below M. So then if we knew that the coordinates of M are, so we do in fact know the coordinates of M are -6 and -3, and we know that the radius is 5 units, we can't just say the y-coordinate of R will be -3, -8. We can't, because of that slant, this is actually then the vertical distance between M and R is shorter than 5 units. So without showing that these two lines are perpendicular, you can't then apply the next knowledge that we're about to apply. So the knowledge that we're applying is therefore the y-coordinate of R is going to be equal to -3 minus 5. Okay, where again, just reminding ourselves, this is the length of the radius. Okay, and so from there, therefore, equation of PR is y is equal to -8. Hi, welcome to a brief afterthought. Okay, so after recording the explanation for all of question 4, I just wasn't content with how I justified in question 4.3 that M and R are in one perfect vertical line. Because pretty much what I said was, well, MR and PR are perpendicular, and so therefore R is directly below M, which is really false because I could, pick a point over there, draw a radius, draw a tangent at that point, and the two lines are perpendicular because of tan rad, but does that mean that this point over here is directly below M? Not necessarily. So there's a bit of logic that I just glossed over because it is fairly intuitive, right? We can kind of just see that MR is a perfect vertical line, but I'm never a fan of just like taking things for granted or just like not stating assumptions or things like that, or not questioning assumptions rather. So I just want to flesh out why it is that M and R are in fact in one perfect vertical line. And the key actually lies in the fact that PR and the x-axis are parallel. So if I just extend, just bear with me, I'm just going to extend PR this way, so continuing as a horizontal line, just extending it a bit more. So we know that the x-axis and the y-axis are perpendicular to each other. That's just how they are constructed. Okay, we also know that these two are perpendicular because tan rad, cool. Then we also know, so this is still parallel to the x-axis, right? So using the fact that these are parallel, we can say that, well, this is 90 degrees as well because they're corresponding angles on parallel lines. But it's also, again, just intuitive, like the fact that a line parallel to the x-axis, the line is parallel to the x-axis, and the x-axis is perpendicular to the y-axis, so it makes sense that this line would also be perpendicular to the y-axis. But anyway, right, so now we see that this angle, let's use our highlighter, this angle and this angle are equal, which demonstrates that these two lines are parallel. Okay, if two corresponding angles on two lines are equal, then we know that those two lines are parallel. So in a very long-winded way, we've shown kind of something that was intuitive this whole time, that MR is parallel to the y-axis. And so what does that do for us? It then, by showing that it's parallel to the y-axis, we're showing that MR is, it's not a slanted line, it's a perfect vertical line, the same way that the y-axis is a perfect vertical line. They have the same gradient because they're parallel. And so therefore, M and R will share the same x coordinate, and then the distance between them will be determined by the change in their y coordinates. So if we know that our radius is 5 units, then we know that R is 5 vertical units below R, and that's why we're able to say the y coordinate of R is just -3 minus 5. So what would I add to what I wrote down initially? So this is perfectly correct. MR and PR are perpendicular, and that also indicates to us in our very long-winded way that MR is parallel to the y-axis, and so therefore R is directly below M. Okay, end afterthought. Okay, then we're asked to figure out the equation of the tangent PS in the form y is equal to mx plus c. That is an interesting one. So what do we have? We have, let's do another color. Oh, sorry. We know a coordinate of a point that is on the line. What else do we know? I guess we could figure out the coordinates of S. Can we? Well, oh, okay. I see. Okay, so, again, tan rad, we have two perpendicular lines, which allows us to get, could allow us to get, yeah, we can get the, no. Oh, yes, okay, we can get the gradient of this line, okay, because we have 2 points, so we can figure out the gradient of that line, which will help us figure out the gradient of this line, which will be one piece of the puzzle solved, and then we can figure out what the coordinates of k, well, we can figure out what c is by using the coordinates of k. Okay, so first task here is for us to figure out, so this is 4.3.2, so we're going to figure out the gradient of the line mn. So that is going to be 5 minus 3, which is just the same as plus 3, and then negative 12 minus 6, which is just the same as plus 6. So that ends up being 8 over negative 6, which is negative 4 over 3. Okay, so that's the gradient of mn. Then we said sm is perpendicular to ps, and that is because of tan rad, right? And so then that allows us to say the gradient of ps is going to be the negated reciprocal of this gradient. Okay, so it's going to be positive 3 over 4. Okay, so now we know that the equation of ps looks something like this. So now we can substitute k to figure out what c is. So sub in k, so that'll be my y is negative 5, and then my x is negative 17 plus c. Okay, so that becomes negative 5 is equal to negative 51 over 4 plus c, and so therefore c is negative 51 over 4. Sorry, confusing myself. Okay, just because I switched sides. So that'll be negative 5 plus 51 over 4. And I think that comes to 31 over 4. So, in conclusion, equation of ps, not that, is going to be y is equal to 3/4 x plus 31 quarters. Yeah, that's good. The line looks like it has a positive gradient, even though we don't rely on the picture too much, but now and again it's just nice to do a bit of a sanity check. Okay, so let's see what Mr. Memo says. So our first answer is correct, y is equal to negative 8, and then the next one we have y is equal to 3/4 x plus 31 over 4. Perfecto. Perfecto. Oh, they actually did such a clever thing in the memo. So in the memo, to figure out the coordinates of S, they recognized that S is the midpoint of NM, because this is 5 units. We calculated that the radius is 4 and the little piece over here is 1. And then this is 5 units. So then to find the coordinates of M, you could use your midpoint, the coordinates of S, sorry, you would use your midpoint formula. That's a good one. What other interesting things did they do in here? Yeah, okay, that's as much as I'm seeing. That's very cool. I would not have thought of that in a million years. So the last part of this question. So again, we're going to start out by filling in everything we know. Do we need anything else? I don't know. We'll see. Okay, the center of the circle is an important one. Okay, cool. So question 4.4, quadrilateral PSMR is drawn. Okay, so we're just joining. Let's do that. Okay, right. That's a kite. Okay, calculate the perimeter of PSMR. Okay, so I mean SM and MR are easy because they're both radii, so we know it's 5 plus 5. As for PR and PS, so what I'm thinking is, okay, we need the coordinates of P, and what we know about P is that it lies on PR and it lies on PS. We have the equations for both these lines, so we know that the equation for PR is y is equal to -8. So we already know that, okay, P has a y coordinate -8. We don't know what the x is yet. And then this one we worked out to be y is equal to 3/4 x plus 31/4, right? Yes. Okay, so we can then just take this -8 and put it over here and solve for x, and that would give us the x coordinate for P, and then from there we could work out the length of this tangent. Okay, and then we know that if two tangents meet at a certain point, right, then we know that they're the same length, right, equal tangents. So we only need to know this length. We don't have to go through the ordeal of working out that length. Okay, so first things first, what are we going to say? We are going to say, we'll say P lies on the line y is equal to -8, okay, because it's the line PR, right? And so therefore we know that the y coordinate of P is -8. Okay, we also know that P also lies on the line y is equal to 3/4 x plus 31/4, because that is the line PS. Okay, and so therefore -8 is equal to 3/4 x plus 31/4. Okay, and then we can subtract this guy from both sides. So -8 minus 31/4, I think that comes to -63/4. Yes, is equal to 3/4 x. Okay, can times both sides by 4. All right. Just so we're working with non-integers. So that'll be -63 is equal to 3x. And therefore, x is equal to -63/3, which is -21. Okay, and so we now know that the coordinates of P are -21, -8. Okay, so just going to write this for myself, -21 and -8. Okay, so then that means PR, right? So this guy over here, his length is going to be what are the coordinates of R? We worked that out somewhere, didn't we? We didn't really. But we did talk about this being, because it's directly below m, then we know that its x coordinate is negative 6. How did I decide that hard? Oh, okay, because it's about to undergo a frenzy. Yeah, okay, whatever. So we know that the x coordinate is negative 6, and we figured out the y coordinate to be negative 8, but that's not very important right now. Okay, so that means that PR is going to be minus 6, the difference between minus 6 and minus 21, right? How much do you travel to get from one to the other? And that's again because this is a perfectly flat line. It's a horizontal line, so we don't really care about what's happening with the y's, because there isn't anything happening with the y's. What we care about is what's happening with the x's. So this comes to 15 units, okay? Right, then I'm just going to bring it back up here, okay? So we know that PR is equal to PS, because tangents meeting at one point are equal. Okay, right? Or tangents from the same point, I guess, depending on how you look at it. So therefore, PS is also then equal to 15 units. Okay, and we know that SM is equal to MR is equal to 5 units, because they're both radii, right? And so therefore, the perimeter that we are looking for is going to be 5 plus 5 plus 15 plus 15, which gives us 40 units. Okay, wow, that was quite a busy one, but very cool. Okay, I'm gonna need to do this on a new page then. So let me do this. Underneath the question. How do I crop? I need to crop. Oh, over here. Oh no, not over there. Okay. We're just gonna indicate otherwise that we did not do this question here. We did it on the next page. Okay, right. So last question, last bit of the question. We are asked to work out the ratio of the area of NPS. So that is NPS. that triangle, divided by the area of quadrilateral PSMR, so that kite that we were dealing with. Okay, so the first disclaimer is I have no idea how to work out the area of a kite, but what I'm going to lean on is the fact that if we just do that, these two triangles are congruent. So if I can work out the area of one, I can work out the area of the other. Of course, we'll have to show that they are in fact congruent, but those are problems for another day. So area of NPS, okay, so we know that the length of PS is 15 units. We know that PS and NS are perpendicular. We can talk about why, but yeah, it should be straightforward to see. We know by tan, right, that this is 90, so this is also then 90. And then we know that this is 5 units long, so we can work out the area of NPS because it's the area of a right angle triangle. So first thing we need to talk about is why angle NSP is a 90 degree. Okay, so we've already told them why this is 90, I think. So we can just then say the angle PSN is 90 degrees because angles on a straight line, right? And so then the area of triangle NPS will be equal to half base. So I'm going to treat this as my base, which is 15 units, times a height, okay, which is the radius of 4 and the little bit here we worked out, which was 1 unit. So that's 4 plus 1, right? So half of 15 times 5, which is 75. Okay, so I'm just going to keep it like that, 75 over 2 square units. Okay, then we need to work out the area of the quadrilateral PSMR. Okay, so like I said, I don't know what the area, how to work out the area of a kite, but what I am going to do is I'm going to prove that PMS, okay, and PMR are congruent. So if I work out the area of one, I've worked out the area of the other. Okay, so how can I do that? We can just use side. So we know that these are both equal. We know these are equal because it's the same line. And we know that these are equal, which we've shown. So that's a nice, quick, straightforward way to prove the congruency. So let's do that. So I'm going to say in triangle PSM and triangle PRM, okay, PM is common, okay, right, PR is equal to PS, which has been shown, and MS is equal to MR because they are both radii. Okay, and so therefore, now we need to get the order of the letters right. So these are 90, so S and R are equal. And then these will be equal. So that will be M, and then lastly these two will be equal. So that will be P. And that is side. Okay, so if I work out the area of the one, I've worked out the area of the other. Okay, and we know that, and we didn't even need the congruency, honestly, like, because we know that this is 5 and we know that this is 15, and we know that this is 5 and this is 15, like, we've shown that before. So we didn't actually even need to do the congruency thing. We could have just worked them out individually and it would have been perfectly fine. Anyway, we like being fancy sometimes. Okay, so the area of triangle SMP is equal to a half times the base, which is 15 units long, times the radius, which is 5 units. So that is 75 over 2. Okay, and we know that the area of triangle RMP is going to be the same because of the congruency of these two triangles. They're identical. Okay, and so therefore the area of the quadrilateral P, what is that letter? PSMR is going to be 75 over 2 plus 75 over 2, which is 150 over 2, which is just 75 square units. Okay, so the first area we needed to work out was the area of NPS, which is over here. And in the second area we needed to work out was the area of the quadrilateral PSMR. Okay, so PSMR, that area is over here. So now we can calculate the ratio required. I feel like let me move some things down. Oh, good Lord. Okay, right, and then remove this one. Okay, so for the first one, our area worked out to be 75 over 2. Okay, and then the other one worked out to be 75. So that's just a half divided by 1. So it just works out to a half. Okay, so that's the ratio that I get. Let's see if the memo agrees. Yes, the memo says it is indeed a half. And for those who are curious, it seems like to work out the area of a kite, you would say half of, oh no, that's what we did. never mind. Yeah, no. Oh, they actually prove congruency for all three triangles, NPS, SMP, and MRP. That's cool. Anyway, thank you for tuning in. See you another time.